After we have learned exponential differentiation, let's look at the more complicated questions over here, D, E, and F. Let's start with D. When I'm given this, I must immediately think of what rule I'm going to use. Notice how it is actually a product of two functions. Hence, I'll be using product rule. So by product rule, I will differentiate first and keep the second. Differentiating first will give me the exponential differentiation, keep the original term, and then differentiate the power, put in front. When I differentiate power, it becomes 2. So I will put the 2 in front. And then I will keep my second term. Then plus or minus? Plus. Differentiate the second, keep the first. Let's differentiate the second one. Differentiate cosine will give me negative sine. And then after t comes the a. Differentiate the angle, I left with 2. Don't forget to keep the first. Now all we have to do is to simplify. So rewrite in simplified form. Okay, so I can leave this as my final answer. But of course, if you want to do one step further, we can factorize common factor. So we see that there's common factor 2 and 2, and also the common factor, the exponential term. So I can factorize it out. Take out the common factor and then put the bracket. What's in the bracket is whatever that I'm left with. Cosine 2x minus sine 2x. So this is another acceptable answer. Now let's come to E. Can I simplify this further? If I can't simplify, then I will think of a rule to use. Quotient rule. So we're going to use quotient rule for this part E. So differentiate top first, which will give me the exponential differentiation. Keep the term, and then differentiate power, put in front. And then I will keep my bottom. Minus. I will differentiate the bottom and keep my top. Over bottom square. So whole thing square. Now we just need to simplify this. So after this step, I can actually further simplify by seeing whether there are any common factors in my numerator. I can factorize out a 3 from 15 and 3, and I can also factorize out the common exponential term. By doing so, then I can see what I can cancel. I can cancel 3 and 9. 3 divided by 3, 1. 9 divided by 3, 3. And I have to simplify it one more time. So this is the answer in the most simplified form. So class, you may be tempted to use quotient rule on this right away. But do you know that you can simplify this further? Okay, I have a base E in the numerator. And you notice there's also a base E in the denominator. Of course, the denominator has power 1. So I can simplify it first. Divide by E on both terms. Division of the same base, I subtract the powers. So 4 minus x power 3 minus 1 will give me 3 minus x power 3. So I can actually use this and do my quotient rule, which will be much simpler. So by quotient rule, differentiate the top first, which will means I will keep the term, and then differentiate my power, negative 3x squared, put in front. Okay, keep the bottom. Minus, differentiate the bottom. When I differentiate 6, it will just give me 0. So anything multiplied by 0 is still 0. Okay, so even though this, I will keep my top. Okay, this whole term will technically be 0. Okay, over, not 6 squared. Okay, now I can further simplify this. After I simplify, I notice that I can cancel. Divide by 18, divide by 18. Okay, so my final answer would be this. Okay, this is acceptable. Or you can even take out the half and then rewrite everything. This is also another acceptable form.